All right, everyone. Welcome back to our equations and inequality review for Math A. So we're going to go ahead and solve these equations. So we're going to remember when we do our equations and we solve for our equations, typically we work with our parentheses, our exponents, our multiplication or division from left to right, and then our addition or subtraction from left to right. And that's if we're solving to simplify them. Now, when we go to solve them, we're going to go backwards. So we need to remember that we're going to undo our addition or subtraction first, since it's now in the number one spot. So on problem number 1, I identify that I have subtraction going on. So to undo subtraction, or the inverse, I'm going to add 12 to both sides. This causes this 12 to disappear. And I have x is equal to 28. Number 2, well, I can go ahead and skip the addition or subtraction because I don't see any, but I do have some multiplication going on. So in order to undo our multiplication, we go ahead and divide. And what I do to one side, I do to both. So I'm left with x is equal to -5. Okay, we're going to go ahead and steal that again from that slide because we remember that, hey, we're going to use this multiple times. Might as well just go ahead and put it over there for ourselves since it's so handy dandy. Yeah, okay, just want to add those extra. So again, we got to start with our addition or subtraction first. Right now I currently see an addition of 2, so I'm going to subtract. Causes to cancel, so I'm left with 8 is equal to x divided by 4. Now I have division, so I undo it with multiplication. So I undo my division of 4 by multiplying by 4. Scroll down a little bit. 8 times 4 is 32. And remember, having the 32 equals x or x equals 32, it means exactly the same thing, just in a different order. And it's okay that we have things different as long as the difference are correct. All right, next one. Again, I am going to start by identifying my addition or subtraction. I see I have subtraction of 3, so I'm going to do the inverse, which is addition. So 7 plus 3 gives me 10. So I have 10 is equal to 2x. This time I have multiplication going on, so I'm going to undo it with my division. Divide both sides by 2. So x is equal to 5. Okay, number 5, there's a couple different ways to approach it. Since there's nothing being added, subtracted, multiplied, or divided to the other side, I can go ahead and start by getting rid of that 3 first with my division since he's being multiplied. Remember, this only works if there's a single number or a single constant on the opposite side. That brings me left with x plus 8, technically in parentheses, but since I've undone the multiplication with the division, the parentheses can be dropped since there's nothing else going on with it. And then 21 divided by 3 is 7. Now we're going to go ahead and undo the addition that I see with subtraction. So I'm going to go ahead and minus 8. And I'm left with x is equal to -1. This one, I have lots of combining going on. I'm sorry, I have variables on both sides, so I need to identify which of the 4 you're going to do. Again, I don't care which of the 4 ways you do it, just make sure you do them correctly, do your opposite signs. So I'm going to do 2 steps in once because, again, I want you to work on what you need to work on, and at some point, you'll get the same thing. So go ahead and pause it and come up with what I've got. Okay, so we should eventually get to 6x is equal to 12. Then we're going to divide by 6. And x should be equal to 2. Again, once you get to one of these problems, there are 4 different ways to start it. One is not more right than the other. They are just different. All right, inequalities kind of are the same thing. We're going to start by we're going to start by solving the same. But if I have a greater than or a less than sign, funny face, my dot is going to be open. If I have it filled in, which I can't do straight from my computer, so give me a quick moment, we're going to have a closed dot. We're going to remember that our sign, our inequality sign, creates an arrow, and it tells us which way to shade, as long as we have X on the left side. And I think that's it. Okay, so we're going to go ahead and, and if you divide by negative, that's what it was. I knew it was. I had my little brain fart for a second. Unique. Oh, I need my A. All right, let's go ahead and tackle number 7. So I'm going to start by dividing by that -7 first. It causes my sign to flip. And 63 divided by -7 is -9. So I draw my number line, which I need to scroll down. Oh, I do have it. Cool. So here's my number line. So here's 0, -9's to the left of that. We have a less than or equal to, so it's going to be a closed dot. I'm going to pull apart my sign, so my less than turns it into an arrow, so we've got a shade to the left. Face. Right, number 8. Again, we're going to go ahead and start with our division, so we're going to divide by 4. And I get 7 is greater than X. But remember, we need to rewrite that so X is on the left-hand side. Well, the 7's currently getting eaten, so 7 needs to continue to get eaten. So here's my 0, here's 7, because 7's bigger, so it should be on the right-hand side. It's going to be an open dot because it's not equal to. And again, we're going to follow our sign and we're going to shade to the left. Same idea. Let's go ahead and start with undoing our addition or subtraction. So first I subtract by 7. Since I've done a subtraction, I haven't done a division. I don't change my sign. So 5 minus 7 is -2. So here's 0, here's -2. Filled in dot because it's equal to, and I shade to the left. Number 10. Again, I'm going to start with undoing my addition or subtraction. Right now I have the addition of 7, so I subtract them out first. 19 minus 7 is 12. Next, I divide both sides by 6. Since my division is positive, the sign stays the same. It does not change. And 12 divided by 6 gives me 2. Here is 0 in relation to 2. It is not equal, so it's an open circle. And this time we're going to shade to the right. We're going to use our different rules above in order to answer this. And I'm going to try and type them because my handwriting's not the best, especially on this. Okay, -2.1 times 1 is equal to -2.1. Commutative, where I move it around. Well, am I doing addition? Nope, I want the multiplication. Commutative, where I move it around. Associative, which means I'm multiplying different orders. Identity, which means I multiply and get it back out. Inverse, which means I multiply by the opposite and get back 1, or distributive, where I move it together. Good, that should be additive, or I can read identity. Because I multiplied by 1 and got the exact same answer out. Number 12. 5 times 1 over 5 is equal to 1. Well, again, we're looking in the multiplication column, so we should be looking there. Well, I see I have an answer of 1. Not equal to 1, not equal to 1, not equal to 1. Hey, 1. Well, if you notice, I have 5 and 1/5. Isn't 5 essentially what my a value would be? So a times 1 over a causes them to cancel out to be 1. So number 12 is inverse. Number 13. 1 plus -1 is 0. Alrighty. Well, I know I can't be in the multiplication because I'm dealing with addition, so I need to look in the addition one. Commutative, where I move them around. Nope, they didn't get moved. Associative, which I add in a different order. Nope. Add by 0, I didn't add 0. Hey, but I got 0 as my answer. So a plus -a is equal to 0. So this one is also an inverse, but he's the additive inverse. And I believe that they want the word multiplicative or additive. So these first two need to be multiplicative. And it doesn't like the word multiplicative, which means it's a variation of multiplication. So it is a word, I promise. Smart Word just doesn't believe me. It's not that smart. Okay, number 14. Again, we have addition, so we can say additive. And what exactly is he? 4 plus 7.8 is equal to 7.8 plus 4. Well, if you notice, they just switched orders. So if I switch orders, which one does that look like? Hey, that looks like commutative. They moved around. So it's additive, commutative. Yeah, I was like, I think I left the letter off somewhere. Okay, 15. I have 1 plus 8 plus 6 is equal to 1 plus 8 plus 6. Well, I stayed in the same order, but let's look at my groupings. At first, I'm going to add 8 and 6 and then add 1. The second part, I add 8 and 1 and then add 6. So which one deals with the groupings? Associative. Oops. And last one. Well, I see everything's being multiplied, so I can say multiplicative. And then again, I see I have parentheses, and parentheses mean order. So it looks like it's just moving my order around. So multiplicative, associative. Okay, we've got 1, 2, 3, 4, 5 more to go. Almost done. These ones we're going to solve for the letter that we're looking for. And remember, even though everything is in terms of letters already, it's going to have more letters out. So I want to solve for y. I need to get y by itself. Right now I have a fraction, and fractions mean division. So to undo division, we simply multiply. So I have 8x is equal to yz. And again, we're going to go highlight whatever we're looking for, and we're looking for y. So there he is. Right now, y and z are being multiplied. So to undo that multiplication, I'm going to divide by whatever is causing the issue. And in this case, it's z. So I want y by himself. So my z's cancel out. I'm left with y is equal to 8x divided by z. Next, on number 18, I'm going to solve for s. And s is here on the bottom. So we need to get rid of that division. And again, to get rid of division, we use multiplication. So I'm left with PW is equal to S times B. again, I notice that my S is over here. I want to undo whatever's causing the issue. Right now, the multiplication is causing the issue. So I'm going to undo my multiplication with division. Causes them to cancel. So S is equal to Y, okay? S is equal to PW divided by B. See, look, 3 more go. Next, we're going to look for Z, and Z is up here in my addition, and it's in my numerator. So, just like the last 2 problems, we're going to undo my multiplication, or undo my division with multiplication. We're going to multiply by what's on the bottom. So multiply both sides by 9. I have 3x, maybe, plus Z. I don't know what this is doing. Plus C is equal to 9 times Y. I'm going to go back and highlight what I'm looking for. I want my Z, so I need to get him by itself. So right now he's being added with the 3x, so I'm going to go ahead and subtract 3x to both sides. But if you notice, 9y and 3x, they're not the same variable. So we just stick them together exactly how I see them. So 9x minus 3x, or I'm sorry, 9y minus 3x. And that's what Z is equal to. Number 20, I'm looking for F, and right now F is being multiplied with E. So I have to undo the stuff that doesn't help. So minus my G and my H. So I have EF is equal to JK minus GH. Go back and identify, okay, where is my F? He's on the same side with my E still. So I need to get rid of the E, and I notice that E's held on with multiplication. So we're going to undo that multiplication with division. And what I do to one side, I have to, of course, to do to everything. So F is equal to J times K minus G times H, all divided by E. Woof, one more. I'm going to move him in the middle. All right, we're looking for Z. Z's on the bottom. Again, to undo division, we're going to multiply by whatever's causing that issue. The Z is causing the issue, so we're going to multiply both sides by Z. So I have MN is equal to YZ. Gonna go ahead and highlight my letter, in this case Z. Okay, how do we get there? Well, right now he's being multiplied. So to undo multiplication, I divide by the issue. And right now the issue is Y. Causes them to cancel. Z is equal to MN over Y. Good luck on your test tomorrow.